Hello everyone, my name is Zachariah Nelson and I will be demonstrating our program today. To start, I'm going to run our program so that it can be producing results in the background as I explain the code. So to start, we have all the important imports that we used to actually create the code and allow us to produce results we need. Then we create a nice little log for all the results. Every time it runs, it will save it in the log file, model logs.logs. We then created part of the code to actually have it pull in the data set, which is the KDD99 data set that will be used on all three models. The first model that we used was the neural network model. This one, we logged it, we had it create the neural network model. We have it with all the parameters we're using to actually have it produce what we need. We'll train the neural network model, evaluate the neural network model, and calculate and evaluate the neural network results. This will provide us a nice accuracy, recall, precision, and F1 score that we can read. Then it will log it in our saved log, which was the model logs.log file. And it will have a nice captions for it so that we can actually see what we're looking at. It results for the neural network model, accuracy, recall, precision, and F1 score. Then it will go ahead and print it out on the screen for us so that we have a nice visual and we can see that it's actually running. Then it will go on to the SVM model and start producing the code or the results for that. It creates a SVM model, calculates and evaluates the model, then it logs it in the log file with the same but different results for SVM, accuracy, recall, precision, and F1 score. And then it will print those out on the screen for us. Next, we have the ADA Boost model. Does the same as it did in the previous models, evaluates, logs, and then prints results for us. This is where it becomes different. Our weighted majority rule vote, that we placed weights on each individual model, declaring that neural network has 0.3 of a weight, SVM has 0.2, and ADA Boost has a 0.5 weight. And that is because of their original when they're ran individually. One has a better score, which was the ADA Boost, had the best accuracy, neural network had the next, then SVM. So with more time, we would have messed around with the weights of each to see if we could improve the results. But at this point, it created better results than when they were individual. We'll calculate it and then log it, print it out on the screen for us. Same as all the other models, but instead having weights. Next, we go into a plotting part. Our plot is a bar graph, and it will plot the accuracy, recall, precision, and F1 score for each model with the model name on the bottom. And a nice key on the bottom right here, allowing us to see which color means what score, and then it'll have the actual results above each bar, showing you the proper results. We have the neural network results so far, so that means it's on the SVM model. As you can see, the neural network is increased to 0.922 as accuracy. The recall is 0.907. Precision is 0.995. And the F1 score is at 0.94. This shows these are all from the individual neural network itself. At this point, The SVM model takes the longest to actually run through all the process to actually give us results. So we will be waiting to get some results from the SV model. I paused the video so we didn't have to wait for results for the SVM model. As you can see, the accuracy is 0.81, recall is 0.77, precision is 0.99, and the F1 score is 0.867. The ADA boost would be 0.924, recall 0.91, precision 0.995, and F1 score being a 0.950. As you can see, out of the three, let me make this bigger. Out of the three, the lowest was the SVM model, which we gave the least weight to. And if you look, the majority vote, the accuracy is a 0.9247, which is greater than any of the three, and that's after the weights were put on each individual model when it did the majority voting. Okay, now we're going to go ahead and look at the graph, which pops up. For the neural network, you can see all the actual results at the top, along with the name of all of the models at the bottom, and you can see how they change throughout with our key on the side. And then next we will go to our logs to make sure that they're actually logging. We will scroll down to the newest. As you can see, we have our majority vote, our ADA boost, our SVM, and our neural network. As you can see, we have saved it multiple times, making sure it worked properly. And in this case, we have a neural network. It's 0.9215 in that one. And in our most recent, it is a 0.922, which is showing that our neural network is learning as it goes, which is also improving. Our majority weight would be a 0.9247. 9247. It doesn't go up too much, but at the end you can see it was a 472. This one is a 473. So we have some results that are improving, but we are still trying to figure out if we can improve it even more. Thank you for your time, and that is our program.